Okay, Assalamualaikum warahmatullahi wabarakatuh. Apa khabar semua? Harap semua para hadirin hari ini sihat. Terima kasih kerana hadiri sesi Ask Expert pada hari ini pada jam 11.30 tepat ya kita bermula. So hari ini adalah hari kedua untuk sesi Ask Expert untuk bulan Mac 2023 di mana semalam kita bersama dengan Datuk IR TS Dr. Badrul Hisham yang membincangkan tentang pembangunan industri dalam negara yang berkait rapat dengan ESG. So untuk sesi hari ini, anda dipelawa untuk bertanya soalan dalam bahagian komen nanti kepada speaker dan soalan akan diajukan selepas sesi pembentangan oleh speaker kita. So I think it's time for me to introduce our speaker. So today we are going to bring you another expert directly from the United States, and he is from Texas A&M University. It is one of the world's leading research institutions known for its significant contributions to the discovery of science and technology. Let me introduce to you Rachel Professor Kevin Burgess. And Professor Dr. Kevin Burgess is a Rachel Chair of Chemistry at Texas A&M University. He obtained his MSc in University of East Anglia, UK in 1979 and gained PhD in University of Cambridge, UK in 1983. So Professor Burgess has taught organic chemistry for more than 30 years and lecturing in more than 10 countries, including Western and Europe countries, as well as South Africa and other Asian countries, including Malaysia. So Prof. Burgess has produced 340 publications with an H index of 82. He has 11 patents and has published several books related to organic chemistry as a main author, co-author, and main editor. So Professor Burgess' research focuses on small molecules interacting with protein surfaces, small molecules for targeting cancer cells, tumor-seeking dyes, and medicinal chemistry of cancer. So without further ado, I would like to invite our main speaker. Welcome, Professor Dr. Kevin Burgess.
Hello, everybody. I hope you can hear me.
Yes, I can hear you very well from here. Good morning. I think it's good evening there in Texas, right? It's around 7 p.m., is it?
It's 9:30 p.m.
I see.
So today I'd like to talk about building a second brain for academics. And this is not specifically a chemistry talk. It's general, so that anyone doing science or, in fact, anything in academics could follow this talk. May I have the first or even the second slide? Now, okay. Next slide, please. Next one, please. Okay, I'd like to talk about the origins of the second brain idea. There was a German academic who was actually trained as a lawyer and decided that he liked psychology more. So he was given an interview at a university and managed to persuade a professor to take him into the PhD program with no psychology background. So he entered the program and he did the first and second stages of a German degree in record time, 2 years. And then he started looking for an academic job. He eventually found one at the University of Bielefeld, and he promised that if you give me a job, I'll solve a really big problem in psychology, and I'll do it before I retire. So they gave him the job. He solved that problem before he retired, but along the way, he published an enormous amount of papers. This professor, Professor Luhrmann, told everybody how he did it, because people were always asking him, how are you so productive? And he said, well, I make cards and I store them in my file index. And in fact, he had a very clever system. So first of all, he would read, he would collect, in other words, information, and he would note this information on cards. And then secondly, he would organize the cards into groups on a different day and a different work period. So far we've got the collect phase, the organize phase, and then on another day, we might distill the information into a concentrated form, write a coherent paragraph on everything he collected on one particular topic. And then in the fourth phase, he would expand, he would create something from the information he collected. So you got it. He collected, organized, distilled, and expanded. CODE. And at the end of his career, he had over 70,000 index cards. So, winding forward a little bit, and this book was written about his achievements and how to take notes in the same way as him, how to take smart notes. It's a pretty good book. I recommend maybe you could read that one. And on the next slide, I'd like to introduce a man called Tiago Forte. Now, Tiago Forte got hold of the same idea: collect, organize, distill, and express. And he called that a second brain. He's published a lot on Amazon Kindle and Mac books, and he has a very active website. And more recently, he's on YouTube as well. Next slide, please. So, how do we collect in science? When Luhrmann did this, he didn't have the advantage of the internet, but now we have so many advantages. We have SciFinder, we have the Web of Science, we have Google Scholar. In chemistry, we have Reacts, we have journal alerts. All those feed into our input. And if anything, today, the problem is collecting too much, making sense of it all. After we collect, we go to the organize stage. On the next slide. Yeah, we organize this into groups. We try to make sense of it all. Please, on the next slide. Now, if you look on the World Wide Web and you search Tiago Forte, and especially if you look on YouTube and you search his name, you will find videos like this one by him, how we organize our life in Notion. And I think there are more, and I believe on the next slide, there are many people doing this. For instance, Ali Abdul has talked about Notion as well. And I think on the next slide, yeah, that's another person there. And there might even be a fourth. I can't see the slides at the moment because somebody else is controlling them. But on the next slide, lots of people are talking about using Notion as a second brain. And I got convinced that this was maybe the way to go. And I spent some time setting up Notion, and you could do it too. It's free for academics, providing you've got an EDU email address. But it never really worked for me. And I was wondering, well, what mistake am I making? On the next slide, please. And then I realized in science, we have everything made so easily for us. The collect and organize stage, the organized stage is a reference database. And there are two really popular ones, EndNote and Mendeley. I do not use Mendeley, but I hear it's very good and it's free. I do use EndNote, and I've been using it for 30 or 40 years now. I've got a huge EndNote library. So with EndNote, you can now very easily, you can go to the Web of Science or SciFinder, you can select a range of references and simply download directly into EndNote, and the references will be in your EndNote library. And then if you want also to download the PDFs, you can download those and link them to each reference in your EndNote library. And then you can open that PDF within EndNote and highlight regions which are of particular interest to you. EndNote is wonderful. Probably Mendeley is too, but EndNote I have a free subscription for at Texas A&M, and I'm very happy using that. So that is how academics, not just scientists, can organize a second brain. Now, the next step, I think, is on the next slide. Don't use Notion. That's all that says. Notion is more general, and it's not really made for academics. EndNote is. And the next slide, please. Now comes this is a display of my EndNote library, or an EndNote library that I made. You can see the linked PDF there. I've highlighted a few words which are particularly important to me, and I could go back and use EndNote now to input citation markers into a Microsoft Word or a Google Doc. And when I'm writing that doc, at any time, I could hit Format Bibliography, and EndNote will work in concert with Word, and it will format all the references in the style that I pick, maybe Nature or Science or JACS, Journal of American Chemical Society, and it will number all the references. If you don't use EndNote these days, you're really wasting such a lot of time. As a PhD student, you have to learn EndNote, otherwise you just make work for yourself. EndNote saves so much time. On the next slide, we can see this is a little video here of me searching on the Web of Science, downloading a PDF. I'm downloading and highlighting a few things there. Doing all this with no hands, very quickly, then writing a little Word document, adding the citation markers that I collected. I made a mini library for this, just drag them across. Then I hit Format in Microsoft Word, Format Bibliography. I say some magic words, and there we are. You see the formatted references, label 1, 2, 3 on the text. Easy, easy. Next slide, please. Now, this expression, a second brain, gives the impression that maybe you just buy a hard disk and you plug it into your ear and it will remember and do everything for you. In fact, no. Now we get to the step that most people don't do, and is probably the most important step in the process. Because every so often, you have to distill these references down. And nothing can do that for you. You have to know what you have to say in relation to the project you're doing and write it down in Word, and then use EndNote to put the references in the right place. On the next slide, this is the key step. Summarize, perhaps in words, for a paper or a proposal or a review. And on the next slide, here you see, I'm interested in proteins called the neurotrophins for something called dry eye disease, DED. And I wrote just 3 paragraphs here, but attached to those 3 paragraphs, I think on the next slide, it shows it more clearly, are more than 10. I think it's 17 references, and they're all very carefully placed. So these paragraphs took me some time to write because they're very concentrated, very, very scientific, to the point, and I collect the references very carefully and put them in the right place. On the next slide, please. Yeah, more than 10 references easily. I think I can see at least 17 there, probably more than that. So it took some time to put all those references in the right place according to what they say. Next slide, please. And then later on, once I've got that Word document, I can just put it into a proposal, or maybe put it into paper and modify a little bit according to what I need to do. But it becomes a valuable resource. Next slide, please. Okay, now that's the key step. That's the one that you have to rely on your real first brain to do. And it's not the only way to do it. I think on the next slide, you could summarize in words, as that says, and on the next slide, or in flowcharts. And this is a flowchart. You see, here I'm flowcharting the process of building a second brain, but you could flowchart the same process of getting all these references together and how they connect to each other. There is a flowchart program which I love because most of these are annual subscription or even monthly subscription, quite expensive. But there's one called Simple Mind out of a company in Holland, and it's a one-time charge. For Westerners and US people, not very expensive, 40 euros. If you buy 10 at once, say for a class, you can get the price down to 12 euros each. A little bit pricey in Malaysia, but very affordable in the US, and I think worth it. I use this program a lot. And on the next slide, the final step is, as I say, to put this together. You could put it together in a document for your PhD committee meeting, or you could put it together in a review or a paper. You could put it together in your PhD thesis. You could make a YouTube video and present what you found that way. This is all an expression of creativity. And once you get to this stage, if you've done the COD steps really well, this becomes so easy. Too many people sit down and say, well, I'm going to write a paper today, without knowing the literature background or how they're organizing their thoughts. They don't flow chart it. But if you've done that work, then the transition into writing the paper is so smooth. The next slide, please. So you can express in a paper. And on the next one, you could express in a video, as I have done. I have a YouTube video on building a second brain, and just search Kevin Burgess. That's my channel, and you will find it. And you will see exactly the same slides, honestly. And on the next slide, please. You could write progress reports and proposals and a thesis. This is all an expression. Now, one little trick that Luhrmann told people is he never does anything he doesn't want to do. So if one day he comes into his office and he starts to collect, and then he hits an obstacle, something that stops him going on, he cannot maintain his state of flow in that direction, he would then switch to another job. He might express by writing a paper, or he might distill some cards that he's collected. If he comes into his office another day, he might be organizing things as his first job. But if you have 4 different types of tasks, maybe on different projects, you don't get bored. You can come in the morning when you're fresh, ignore distractions, don't check email, don't check SMS or anything like that. Get straight on with your job and know what it is. Today I'm going to organize those cards I collected last week. Next slide, please. And you might even, having written the paper or published a YouTube video, you might repurpose that as a talk. And actually, that is exactly what I'm doing now. I published my YouTube video. I'm using the same slides and the same information to tell you about life. Next slide, please. So in conclusion, first collect. Next slide. Then organize, probably in EndNote. Next slide. Distill into Word using EndNote to put the references in the right place. And next slide. Express, present, or publish somewhere. Coda. A code, actually. It should be according to this flowchart. Code. Next slide. Now, if I have a few more minutes, shall I speak for 5 more minutes? Or I could stop now. It's either is good.
It's fine from us. I think it is an interesting topic to share for all of
Okay.
us, especially. Yeah.
Okay, so I want to tell you about a children's book. There's a children's book that I was reading recently. I love the books, and actually I've lost my slides. Could you please put them back up again? I can't see. That's it. Yes, and I was thinking about how this child's book is written in a very clever way. Let me tell you what it said. I wonder if you can repeat this after me. It said something like, when Tweedle Beetles do battle in a bottle on a poodle eating noodles, we have a Tweedle Deedle bottle battle on a noodle eating poodle. So I thought about that sentence, and I realized, well, the first part of it is saying something quite descriptively, not being economical with words. And then the second part of it is a much more concentrated way of saying something. And of course, in science, you want the concentrated way. Clarity, organization, and minimum amount of words usually works the best. So I did a little exercise this afternoon. And on the next slide, I picked a victim. So this is 3 paragraphs from a book I read recently. It's not really a science book. I suggest you don't try to read it yet, but you can see 3 paragraphs, it adds up to 159 words. Now, one time when I was working on a legal case, actually, as a consultant, I was interacting with a lawyer, and he did something very clever with the claims. He deleted every irrelevant word, and then you're left with the bare bones of what the claim is really saying. It said almost nothing. So whenever I have a piece of text that maybe I've written and I want to start distilling it down, giving it in a concentrated scientific form, I start by deleting unnecessary words. So on the next slide, yeah, I just picked on some words here that I felt I could strike out of this person's paragraph, and it would still mean the same, and it might even read better. So I did that, and on the next slide, what was 159 words became 138. And when I read that, I think it is better. What I find in scientific writing is every time you can say the same amount that's necessary in a shorter number of words, a lower number of words, it gets clearer. After deleting words, then I play with the sentences just as in that children's book. I rewrite phrases in a more concentrated way. And I think I've indicated that on the next slide. So I picked one paragraph here. I picked the first paragraph, and that's how it was, I think, after I deleted a few words. And then I looked at this carefully, and on the next slide, I decided that that paragraph on the top could become something written down the bottom there. And every time I put something in red, that's a change that doesn't change the word count. And every time I put something in pink, I added a word. So I added and, the word and twice, but you see all the gray words there? Somehow they disappeared when I restructured that paragraph. So on the next slide, that became that little paragraph at the bottom there. You see the top one was 4 lines long, and the bottom one is just over 2.5 lines long. So when I applied that technique to all 3 paragraphs, on the next slide, after deleting words and restructuring, 159 words came 138 after deletions, and then I got it down to 86 words. And when I read those 2 paragraphs now, I incorporated one paragraph into another, because that one paragraph at the end was only 1 sentence long, then I think that reads far more clearly than what was in the book originally. Short, brief writing in a concentrated way, structuring your sentences very carefully, pays dividends in science. And then after you've done that, think carefully about where the references go in the distillation step. On the next slide. Thank you very much for listening to me. I'd love to take questions if anyone has them.
Thank you so much, Professor Burgess. That is very interesting way of delivering on how we can manage references and information in a very flowy method. So I think my first question is, I can see that you did this paraphrasing in steps. It's a step-by-step process where you first detecting the main key points from the sentences, and then you try to merge them and make it more concise, and then you analyze them again and synthesize it again to make it a much more concise sentence. So at the end, I was wondering, how do you include all the references? Did you have another page of paper or a note besides uh, from the sentences that you have compiled? And then, because when we make it the sentences much more concise, we might miss from where this sentence might come from. So, how do you manage this referencing system by referring to the latest and concise sentences?
Well, of course, you mustn't copy sentences from anyone. That would
Yep.
be plagiarism. So I write the sentences myself. I know what I want to say. And then as a scientist, whenever I make an assertion, I say, really, this is known, then it needs a reference. And then, of course, you have to dig into the references that you've organized and know which one of those goes with that particular thought. So if you spend time, first of all, reading the references, then organizing them, then it's not too much work to pick out the right one. Now, sometimes the first part of the sentence makes one assertion, and the second part of the sentence might make another. And so I'm actually quite careful to put the right reference on the first part of the sentence and the other correct reference for the second part of the sentence there. And then occasionally, when I'm distilling things down, I create almost a list in one sentence. I might say the methods for making these compounds um, are known, and they rely on palladium, platinum, rhodium, and iridium. I'm just making all this up, but the reference for palladium will go after that word and a comma. The reference for platinum will go there and nowhere else, and the reference for rhodium will go there, and the iridium one will go there. What I don't do is collect all the references together and or put them in as one, because then the reader doesn't know where to go to look, particularly for rhodium or iridium.
Uh-huh. I think that is a brilliant answer. Thank you so much for that. And there's another question from the audience. All right, this is general question, which is students always have problems to express. Is there any shortcut way to easily express our results and findings?
Um, well, I'm
This is more
afraid.
to expression. Yeah. How can we express? I think this is more to discussion part of the
Yeah,
results and findings. Yeah.
I think shortcut way. There's no substitute for practice, but there are there are procedures that we can follow. So if we sit down to write the paper, start with the easiest section because that will give you some progress to build up. So first of all, you must have everything distilled and organized. Actually, the very first thing is to collect all your literature references and draw a beautiful graphic.
Mm-hmm.
Referees
Yes.
judge your paper often on the pictures. They're just like babies. They like nice pictures. And so if you draw beautiful graphics, then that gives you a head start getting your paper accepted. Then once you've got the graphics, put them in order in a manuscript template and do the easy parts from then on. The easiest thing to do is put in the experimental. Every person, every scientist who's an experimental scientist can write an experimental procedure. So do that, get all your data organized, and then the next thing would be the description of the results. So once you have the figures in the right order for the results you've accumulated, you simply describe what's in the figures. Then you might write the conclusion. The conclusion really says what the figures show. And then finally, well, not finally, but almost finally, you go to the hardest part, and that's writing the introduction. Now, if you write the conclusion first, you might write the introduction So if you write the conclusion first, you know where the introduction should be pointing to. But a common error is to promise something in the introduction because I don't really understand where the paper is going quite yet. And then the referees, if that persists in the final draft, the referee will say, well, Burgess promised this, but he actually delivered that. He failed. You don't want that. You have to build up in the introduction the problem that you've solved or why what you found is very interesting. After you've
Mhm.
done all of that, the abstract, and then refine the title. The title should tell exactly what you've done. So there's no shortcut. You have to practice, but um, it's easier if you know, don't do it in the order in which it's presented in the paper. That's not the way to write it.
Yeah. That's another brilliant answer. Thank you so much, Prof. Burgess. I think the main point here is not to find the shortest cut to write the results, I mean, to interpret the results or the findings, but to find some way to organize and make it more concise and clear and easy to see so that we can synthesize something out from there. So I actually have some experience with Notion, which I think is good for, I think that is for reading. I think reading um, like for newspapers or any other information from the websites. But yes, I do agree with you. It is not really suitable for case where we have to read research papers. And I think, as you have mentioned, EndNote is one of the softwares that is good for organizing this paper in a much more um, I mean, it is very helpful for us to retrieve back the information and the PDF and the organization itself. So I'm just wondering, there is a lot of softwares out there other than EndNote, which you have mentioned another one which is Mendeley, and there's another one Zotero. So in your opinion, I just wondering why are you referring why are you preferring EndNote compared to Mendeley? I realized that you mentioned that it is much easier using EndNote. Is there any other pros and cons or comparatively that you can say about these three softwares?
I'm afraid not, because in honesty, I started using EndNote before the others existed. And I just keep adding to a massive library, and it would take a very persuasive argument to make me change at this stage. So
Mhm.
happy with EndNote. It seems to do everything I want to do. And until someone tells me that Mendeley can do something different that EndNote can't do, then I will stick with EndNote. But if you're new and starting, you might investigate all three. It may be that you don't want to pay for EndNote and your university doesn't pay. That's fine. But EndNote will do other things. You can link websites into EndNote. You could screenshot newspaper articles if you wanted to and put them into EndNote as well. You can add keywords to each thing that you've entered. So you can search on those keywords to organize in that way. EndNote is a very powerful program.
I see. All right. Thank you so much for that. So your way of presenting is very well expressed and it is very flowy. I think the main point here is also to use mind map or flowchart to make things much easier to see. So I think there's one um, how to say request from the team. Can you please, because you are going to be one of the speakers in our upcoming event in MIC, Multidisciplinary International Conference, which will be held in Bangli Hotel Tenera at, from 6 to 7 of March. So could you please briefly explain a little bit on what are the topics that you're going to share during the session, during the conference?
Ah, well, in the conference, then I am talking mainly to chemists and biochemists, and then I get much more technical. Um, so in the conference, I will start by showing an interaction between two proteins, and one of them is the spike protein from the COVID virus, and another one
Mhm.
is a protein that we have in our body, particularly our lungs, called ACE. And these two proteins, when they interact, there's a helical region on one of them that interacts with the other. There's an interface, and a large part of that interface is a helix. So what we do in my group is try to mimic helices like that and hold them into a helical conformation solution. Because unlike a protein, which can be quite stable as on its own, a peptide, a smaller fragment of a protein, will tend to unravel and it will move like a snake in solution. If that happens, it's hard to get it to fold back up and interact with one of the proteins. And what we like to be able to do is make peptides that persist in a helical conformation and can displace the protein ligand. And when they displace it, they could either have agonistic or antagonistic activity. So I won't be talking about COVID much more than that, but I will be talking about new helical mimics that we've made, and we just published our first paper this week, I think, in ACS Central Science.
Oh, that sounds great. So, because I have very basic idea on um, computational analysis, which is in silico study, which is only based on the molecular docking. That's very basic, very, very basic. So I think hearing this session during the MIC would be so beneficial for us, especially for those in chemistry. So yeah, is there anything that you would like to say to the postgraduates out there?
Um,
Yeah.
it's a great time to be young, and I think that what I'm finding right now is I'm enjoying making YouTube videos very, very much. I enjoy them just as
Yes.
much or more as writing papers. And
Uh-huh.
within a week, I'm not a very popular YouTuber, but within a week, I can have 200 people viewing my video. And I'm sure sometimes when I put a paper out, no more than 20 people will read it carefully. So I'm enjoying making videos, even making videos of my paper. Um, if I was starting, I would put much more emphasis on videos than most of my colleagues do. I don't know anyone at Texas A&M who makes videos like I do at the moment, but I think they should because that's what particularly young people will want to watch. They can do it on the bus, on their cell phone, or whatever, and it gets the message out about your science. If I understood how to add something to the chat, I would add a link to a video I've made on the helical mimics that was
Uh-huh.
just presented. But I'm not sure how to add something to the chat. I can see
Uh,
comments, you can see private chat. When I go to comments, then there's no space for me to add a comment myself.
it's okay. I think the team has the links. So later on, we will share in the Dr. Rocket's Facebook to everyone to have an access to the links. Yeah, because I understand that you have your own research group, which is known as the Burgess Lab, which is very interesting. There's a link for that too, which we will be sharing. Maybe the team will share the link so that everyone can have the access to your research input. So, if there is anything else that you want to share about the your research, Prof. Burgess,
Not really. I
because
just added a link to that video I made on the helical mimics to the private
I
chat
see.
channel. And I've added one on
Right.
making second brain in silence. And the name of my channel is Kevin Burgess.
I see. I've seen some of your YouTubes, and it was very interactive. But I think it is also important to share our research, or I mean your expertise through YouTube, because it is much more interactive other than just expressing it in your publication and books.
And thank
All
you for
right.
all the nice comments that I can see here. Some people have written some very nice things. Thank you.
All right. Okay. Thank you so much, Professor Kevin Burgess.
Thank
So,
you.
thank you so much. We will see you again during the MIC conference in Tenera Hotel in March
Okay.
6 to 7. Thank you so much. See you
Bye bye.
again.
Take
All
care.
right. Bye bye. Take care. All right. So, our session with Professor Kevin Burgess, he was um, having his session is actually from straight from the United States. So, it is very honored to have him as our speaker today. So, I can switch my language into bahasa Melayu now, right? Okay. So, sebelum saya mengakhiri session ni, saya nak jemput anda untuk hadiri pada seminar ataupun conference kita pada 6 hingga 7 Mac, iaitu conference multidisciplinary pada 6 hingga 7 Mac lah di Hotel Tenera Bangi, dan kita mempunyai ramai pakar-pakar bidang termasuk Profesor Kevin Burgess sendiri, iaitu merupakan pakar bahagian kimia perubatan, dan dia adalah daripada Texas A&M University. Dan kita juga ada pakar lain, contohnya macam Prof. Dr. Asim yang merupakan pakar dalam bidang bahasa Arab dan linguistik, dan kita akan ada juga mantan VC UKM pertama wanita, iaitu Profesor Emeritus Tan Sri Datuk Seri Sharifah Hafsah Syed Hassan Syabuddin, dan juga salah satu pakar yang juga akan ada adalah speaker yang join kita semalam, iaitu Datuk IRTS Dr. Badrulli Syamsul. MIC masih terbuka untuk para peserta sahaja dan juga dinner. Kalau nak join boleh, masih boleh, masih dibuka, boleh contact team. Dan juga pada 3 hingga 5 Mac ni, sebelum MIC, kita akan ada satu program yang besar juga untuk semua pelajar, tak kisah untuk postgraduate student ke, untuk diploma ke, degree ke, ataupun yang lepasan sekolah menengah ataupun masih belajar dalam tahap sekolah menengah. Sangat-sangat bagus untuk datang sebab program PTPT dia lebih kepada program transformasi, dan PTP itu sendiri bermaksud program actually PTP is Postgraduate Transformation Program, tapi kita nak buat satu pendedahan di mana kita akan berdiskusi ataupun Dr. Wakil akan kongsilah tentang bagaimana kita perlu kata ada strategi untuk transform diri dan kepentingan pendidikan, ya, sebab zaman sekarang ni ramai budak-budak ataupun pelajar sekolah menengah kita, ya, dah kurang berminat untuk sambung belajar, especially yang lepas SPM. Jadi kita nak revolutionize balik minda kita supaya kita meletakkan kepentingan untuk belajar. Okey, dengan itu saya akhiri sesi ini dan semoga kita berjumpa lagi dalam As Expert, dan jangan lupa untuk daftar PTP dan juga MIC pada bulan Mac nanti. Okay, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.